When you're doing A-level maths, chances are you come across partial fractions on quite a regular basis, and there are some common mistakes that you're probably making that you're not even aware of, and that's leaving you stuck during the exam and leaving you unable to really do anything. So in this video I'm going to be showing you what those common mistakes are, how to solve them, and the general method that you should apply when going forward with partial fractions. Let's get into that. One of the most common mistakes you're facing, chances are, is either one of these two, and that is not dividing first or not using the right decomposition method. The second one is kind of obvious, we'll get to that in a second, but not dividing first, what does that look like? Now, what does not dividing first look like in practice? Well, here we've got an equation, looks relatively simple, right? So if we break this up, get x minus 2, x plus 2 at the bottom, and according to our basic logic we just get a plus b, right? And then we can then simplify. Okay, we can set x equal to negative 2, which means that negative 2 squared is going to equal negative 4b, right? And there's only one problem with this. The problem is that this is entirely wrong. On the other hand, over here we've got the mistake of not using the right decomposition method. So again, over here we might say, well, x minus 2 so that's going to equal a with 2x minus 1 squared plus b over x minus 1 squared, sorry, over x minus 1. The problem is with this is also entirely wrong. So then, what's the solution here? The key thing to remember are these 3 points, and typically if you follow these 3 points you can figure everything out on a common sense basis, and just knowing these would probably help you out a big deal. So basically, if the degree of p of x is smaller than the degree of q of x, then you're fine. But otherwise you need to do long division. Next, factor q of x into a product of linear and irreducible quadratic factors. Okay, and 3, when you, for the denominator, you need to repeat that n times. So for instance, x plus 1 to the power 3, you do x plus 1, x plus 1 squared, x plus 1 to the power 3. So what does that look like in practice? Back to this example, what we're going to do instead is we're going to divide x squared plus 3x plus 1 by x squared minus 4. Right, so if we do x squared minus 4, and this is taking into account our rule here, okay, so that goes in once, okay, we got s squared right, so what does that give? Well, what that gives is 3x okay plus 5. So therefore what we can say is x squared plus 3x plus 1 over x squared minus 4 is going to equal to 1 plus 3x plus 5 over x squared minus 4. Okay, brilliant. So we've got this bit, but now for this we can then say, okay, 3x plus 5 over x squared minus 4 is equal to 3x plus 5 over x minus 2, x plus 2, okay, which equals a over x minus 2 plus b over x plus 2. Okay, which means that 3x plus 5 is going to equal a x plus 2 plus b x minus 2. So if x equals negative 2, Okay, we got negative 4b here. Okay, so we've got negative 6 plus 5, negative 1. B is equal to a quarter. Okay, and if x equals 2, well, what does that give us? It's 4a, and we can say that a then is going to equal to 11 over 4. So therefore what we actually get in this instance is going to be 11 over 4x minus 2 plus 1 over 4x plus 2, and that will be the decomposition. What about this mistake? How would we do it here? Well, in this instance we'd say this. Well, remember, what do we see? N equals 2. Okay, so we are repeating, so x minus 2 with 2x minus 1 squared, x minus 1 is equal to x minus 2. Sorry, that should be a over 2x minus 1, 2x minus 1 squared, plus c x minus 1. Okay, and then we can multiply that out, and if we multiply that out, x minus 2 is equal to a times x minus 1 plus b. That should be x minus 1 and 2x minus 1. Okay, because it's repeating. Okay, then it's plus b x minus 1 plus c 2x minus 1 squared. Okay, and so from here we're going to equate coefficients, and the reason we're going to do that is because if we just plug in x equals 1 or x equals a half, then we're going to find it difficult to find a. So we might as well just do the coefficients method. So if we do that, what can we do? Well, a, we've got 2x squared minus x minus 2x plus 1 plus bx minus b plus c 4x squared minus 4x plus 1. Okay, 2ax squared minus ax 2ax plus a plus bx minus b plus 4cx squared minus 4cx plus c. Okay, and if we rearrange all this, what do we get? Well, if we rearrange all this, what we get is 2a plus 4cx squared plus minus 3a plus b minus 4cx plus a minus b plus c. Okay, and so what do we get then? Well, 2a plus 4c is going to equal 0. Okay, and a negative a plus b minus 4c is going to equal 1. Okay, and then lastly, a minus b plus c is going to equal minus 2. So what can we say? Well, I can say that 4c is equal to negative 2a, okay, which means then negative 3a plus b minus 2a is equal to 1. What does that mean? Well, it means that negative a plus b is equal to 1. Which means that let's see, a minus b is equal to minus 1. Okay, so therefore I can say negative 1 plus c is equal to minus 2. C is therefore going to equal add 1. So -1. Okay, c equals -1. 4 -1 is equal to -2a. -2a is equal to -4. A is equal to 2. Okay, and if a is equal to 2, therefore 2 minus b is equal to -1. B then is going to equal 3. Okay, and that's your final answer. Again, all it comes down to is using the right decomposition method. In this case, we were repeating. Guys, now for 2x minus 3 over x cubed plus x, right? What do you notice about this? Well, the degree here is less than the degree here, right? So this means we can decompose this in a certain way. And the way we're going to do that is we're going to say, well, 2x minus 3 over x cubed plus x, okay, is equal to 2x minus 3 over x squared plus 1, okay, which equals then ax plus b, right, over x squared plus 1 plus c over x. Okay, right, so this is because we've got an irreducible factor here. So, okay, what is that irreducible factor? This is the irreducible factor, x squared plus 1. So, now we can just say the following. Well, 2x minus 3 is going to equal ax plus b times x plus c x squared plus 1, right? So from here what we can say is, okay, let's multiply this out. Get ax squared plus bx plus cx squared plus c, which means that 2x minus 3 is going to equal a plus c x squared plus bx plus c, right? So c then is going to equal -3 off the dot, because look, we've got -3 here, we've got c here. Next, a plus c is going to equal 0, so therefore a minus 3 is equal to 0. A is going to equal 3. And if that's the case, well, b equals 2 as well, we know that, because it corresponds to the x. Therefore, what do we get? 3x plus 2 over x squared plus 1 minus 3 over x. Okay, and that's your final answer. Again, this is all because we had an irreducible quadratic factor. Alright guys, now in this example, we're stuck with yet another irreducible quadratic factor. So, we're going to start off by looking at this. X cubed minus 8, right? So if we look at this, we can say, well look, x cubed minus 8, in fact let's put an equal sign. If we break that up, what do we get? Well, we know that if we factor this, okay, we can get x minus 2, x plus 2, x minus 2, right? And so, what does that look like? Well, what that results in is x minus 2, x squared plus 2x plus 4. And so, this is naturally irreducible. Okay, that's irreducible. So therefore what we get is 1, okay, over x cubed minus 8 is equal to this here, which equals, okay, a over x minus 2 plus bx plus c over x squared plus 2x plus 4. Right? Brilliant. And so we do the same process again. Now we're just going to say 1 is going to equal a x squared plus 2x plus 4 plus bx plus c, okay, x minus 2. Right? And in this example, it could be easy enough to just, let's see, let's be concrete here. Say ax squared plus 2ax plus 4a plus bx squared minus 2bx plus cx minus 2c. Okay, now if we factorize this, put it all together, okay, x constants. Okay, so if we put the x squares together, we get a plus b x squared, okay, plus 2a minus 2b plus c x plus 4a minus 2c. Right, so a plus b is equal to 0. Okay, and funny enough, 2a minus 2b plus c is also going to equal 0, and 4a minus 2c is equal to 1. Okay, so what can I put in here? Well, a is equal to minus b. Okay, so therefore here minus 4b plus c equals 0, c is equal to 4b. Right, so if c is equal to 4b, then we can say, okay, 4a minus 2, 4b is equal to 1, and 4a minus 8b is equal to 1. Now a is equal to negative b, negative 4b minus 8b is equal to 1. So b is going to equal negative 12th. Okay, so if b equals negative 12th, therefore c is equal to 4 times negative 12th. Well, c then is just going to equal negative 1/3. Right? And therefore, what's a going to equal? Well, a is going to equal 1/12. Okay, so therefore, what do we get? We get a plus bx plus c. So negative 1/12 x minus 1/3 x squared plus 2x plus 4, and you can simplify that as required. Okay. Guys, so now this is where partial fractions really come into play, and this is important because ultimately the goal of partial fractions is to make integration easier. Right, in 90% of cases they're going to be linked together. So how does this work? Right, so here we've got a classic integral, and we're going to use integration by substitution, right, because we've got cos x dx over there. Okay, which means that we're going to have du dx. So yeah, we're going to have a du by dx there. So therefore, that must imply that u is going to equal sine x. Okay, because therefore du by dx is going to equal cos x, okay, which means that du is going to equal cos x dx, okay. You can think about this as just having the cos, obviously having a 1 here and times it by cos, right, so cos x dx. So easy vibes. So we're just going to say, okay, we've got 1 over u squared minus u du. Okay, now watch here. How would you go about doing this? Give it a try quick. See what you get. Pause the video if you need to. But what I'm going to do is take out the u, and we have what u minus 1 du. Okay. Now, this then can be applied to say, well, if we expand that, we're going to get a over u, okay, plus b over u minus 1. Okay, so therefore 1 is going to equal a u minus 1 plus bu. Now if we set u equal to 1, what does that give us? Well, if u equals 1, then b is equal to 1, right? And if we set u equals 0, then 1 is going to equal negative a. So a is equal to negative 1. So therefore what we get is negative 1 over u plus 1 over u minus 1. So therefore, if we transform this now back into our original function, what we've actually got is the integral of negative 1 over u plus 1 over u minus 1 du. Okay, that's going to give us negative ln u plus ln u minus 1 plus c, which gives us negative ln sine x plus ln sine x minus 1 plus c. Okay, and that's going to be your final answer there.